Hello, everyone. Welcome to ITS 372 sysadmin. So video's recording and audio is on. Okay. So let's get started then. I'm going to share Brightspace. Okay. So I'm sharing Brightspace now. So let's go to the content section. And here we are. So as you can see, we've covered basically, like 1/3 of the semester already. That was really like the intro to Linux, getting a feel for Linux. So hopefully by now, if you haven't, you've had a lot of practice. I don't expect you to be an expert at Linux or an expert at scripting, but I expect you not to be afraid of it anymore, right? So that's really the thing. You should be getting comfortable with it. You'll practice a lot. So that was the first 6 weeks. Now in the next 6 weeks, we're going to start getting into a few more advanced topics, right? So this week we're going to start, we're going to focus our attention on just one service, which is going to be DNS, domain name system. So we'll take a look at that. So today I'll do a lecture on this. And this, of course, as you might imagine, is associated with a lab. And the lab is actually, should be a lot of fun. It's going to be one of the seed labs. So you can definitely, one recommendation, since you will be taking 350, 454, and a whole bunch of classes related to security, is that you should get the book by, the book, what's it called? I have it here. It's called
Computer Security, a hands-on approach.
Yeah, exactly. I have it here. The book is called, although we're not going to use, I don't use this book that much in this class. That's the reason why it's not in the syllabus. Computer and Internet Security, a hands-on approach, the latest edition by Wen Liang Du. So you will use this book extensively in 350, 450, and 454. A lot of chapters. In this class, I only do one chapter from the book, which is DNS. Okay, so I strongly recommend, if you haven't gotten that book, get it. Believe me, it's one of the most valuable books in this program. And then start reading or read along chapter 15. Obviously, you don't have to. I mean, I'm going to give you all the material, but I'm just saying, if you're one of those students that likes to read along, and that's how I used to be. I would read everything, right? So certainly get the book. A lot of what I'll be saying comes from there. A lot of my notes come from there, etc. All right, so and you can see I have the slides are here as well, so you can just take a look at those. And then this will be the lab. So actually, I like to motivate what we're talking about in the lecture by first, kind of looking at the PDF. So the next, I like this topic, DNS. I think it's a really nice lab for several reasons. Just be aware, next week we'll cover account management, so that, user account management is pretty important. That should be a pretty easy lab, I think. Not many, it'll have one scripting problem. And then we'll do this one, the Hadoop. This is a very important topic. Make sure you pay attention to this, because as you know, at the end of the semester, you have a project. Actually, you have Project A and Project B. Project A is a bit tough to do, because Project A requires you to take 3 computers, 3 VMs. It's a group project, obviously, 3 VMs, and you're going to put them together in like in a network, right? In a LAN. So the 3 computers will need to work as a cluster. They need to work as a single computer. And the reason why I do that is that I have found that it is a very good installation and sysadmin in Linux problem, okay? So first of all, I'm not going to give you any materials for that. That's just you proving to yourself that you can, in fact, you know, sysadmin Linux, right? So that's the idea. So you will have to go online, make a lot of decisions about which VM you should be using that is appropriate for this, do the configuration, and run a job. I will explain, you know, what job I want you to run and everything. But as I said, this is a project. So this is your term project. So if you think about it, today's lab is the start of that sequence. Okay, so obviously everything that you've done so far in the semester from the beginning also led up to this. It's given you enough background to have a good understanding of things. The Hadoop lecture, I do it, you know, obviously week 8 or so, and then you'll have about 8 weeks to get these 3 computers clustered together. And in particular, as I said, it's about proving to yourself that if you, let me put it this way, if you can configure Hadoop, 3 computers in a cluster in Linux, you can do anything, right? So that's kind of, it's not meant to scare you or anything, but it is a bit, it requires concentration for sure. And so it requires quite a bit to just even do the task that I want you to do. This has to do with data science. I'll talk a little bit about data science and what that entails, and how a person that knows Linux could support, you know, a company. Nowadays, a lot of companies have data science, you know, practice or whatever they want to call it, an office. And so, you know, they might call you up and say, hey, you know, we're setting up the data science and we need somebody to configure our Linux servers. And then, you know, and also run the jobs. You know, okay, I want you to run this job or that job, or, you know, they have a problem that needs solving, etc. So as you can see, a lot of this is problem solving, you know, with Unix, you know, either to get something set up or just using Unix itself. Account management is also, it has to go before Hadoop because you have to create some accounts and groups and things like that, permissions, and so that's important. Now, how does DNS fit into it? Well, DNS will be the first time that you, in this semester, in this class, of course, that you will configure 2 computers that should work together. Okay, so you'll do the client server architecture that we're very familiar with. So you will need to have a DNS server. We'll use Bind 9 or the latest version for Linux as the server, and then you're going to have a client that needs to use DNS. So this configuration of Bind 9 is a little bit more complex than any other configuration that you've done before, but it does not compare to the configuration of Hadoop. So this is just a warm-up. So the DNS configuration is just a warm-up for obviously the Hadoop, which is a term project, Project A. And then I'll talk about Project B later. But as you can see, I've already now, you know, we're almost at the middle of the semester, the halfway point. So you really want to start thinking about forming groups of 3, right? So find your friends, start forming your groups of 3. Keep in mind the project, the Hadoop Project A, at the end of the last week before finals, you will have to demo to the class, not just to me, but to the class, and look at the demos of your other friends and just see that you configured things successfully. Of course, I need to give you all the theory and everything, so I'll give you a lecture on that. But yeah, that is the plan. So it's basically a sequence starting with DNS where you do pretty easy configuration, but obviously also much more complex than you've done so far. And that's a warm-up for the Hadoop one. In between, we got to go through the account management, and then later on in the third part of the semester, we'll covering like monitoring services, etc. Now the DNS lab, so now that I've talked a little bit about that, just to kind of motivate that this ties to the project, I can focus basically on DNS Lecture. So you can see I have some slides over here, and these are those slides that you have to download. They're invisible on here, but there's data there, just download it. And it'll be basically my notes today will be exactly the same thing. Now, let me open up the PDF here. So this will be the document PDF. That is your lab. As you can see, these are the seed labs. They're pretty good, like really good labs. always get into the habit of reading the entire document very carefully. I will go through it today, of course. But you have to do this, right? Remember, you're in IT, you're a problem solver, right? You're not a tutorial reader, right? So you have to solve this problem. Of course, I'll give you a lot of information about it in the lecture today, and we'll have some time on Wednesday to go over this. I am not sure how long this will be. This could be a 2-week lab or it could be a 1-week lab. It just depends. We'll see at the end of Wednesday how you guys see it. So it's a fun lab, though. I should say it's a really nice lab because the goal is it's got two goals, and then you actually achieve something third. So the first goal is really configuration, right? So you're going to put on your system administrator hat, and you got to configure. You got a server that is at default, and you got to configure bind 9. So that basically means you can see it's got commands like sudo service bind 9 restart. So these are a lot of the commands that we've already seen in the semester, right? That I kind of the name servers we'll talk about today, but these are a lot of the things that that you've done, practice, just a little bit of practicing on your files, opening files, etc., navigating, right? And so you'll get to practice configuring a complex service, a slightly more complex service. Remember, all of this is about services. Just like this was email, right? This could be email services, and then you would have to configure it in Linux and get it to work. Well, this is what this lab is. That actually reminds me to tell you what part B of the project is. So part B, whereas part A was configuring that Hadoop fixed problem, part B will be just picking a service. So there are so many services in Linux that I can't really cover all of them, right? Like, we'll cover a few. And so usually that allows us in the term project to cover other services. For instance, let's say that I don't get to cover the email service in Linux this semester in a lab, etc. Then that's your part B project. In your part B project, your group decides, oh, by the way, we want to configure email on Linux, and we're going to do a demo of it just to show some basic functionality. So that's, project B. So again, at this point then, if you think about it, I've talked about project A, project B, and you kind of have a sense of what it's going to be. So that's why the DNS lab is so important, because the DNS lab kind of takes you into the view of what the term projects are going to be, okay? So obviously in this lab, this is a lab, therefore there is a lot of documentation in the lecture, the notes, all of that, this PDF, the book, but your projects A and B are similar to this, where you have to configure a service, either Hadoop in project A or in project B, that's, which you have to do both, a service that you pick. But you do the configuration, and obviously it's not just, okay, I'm done, I configured it. Obviously you have to demo something related to that service. So you have the service, it works, okay? So again, that's why, usually after the exam, I always do this DNS lab. And it's, it helps me at week 7, which is where we currently are in the semester. It helps me to kind of throw at you the term projects for the semester, which, as you can see, they're not that big of a deal. They're each of, in a 300 level class, where you still get some assistance before you're a senior, the projects are not worth that much. So if you look at the syllabus, both the term project is only 10% of your grade. So obviously project A will be 5 points and project B will be 5 points, okay? So just be aware of that. And as I said, it is a group project. It can be the same group for project A and project B, and you will do those 2 demos at the end of the semester. So this is a large class, so obviously we will need the full week before finals to do the presentations. But that's the idea. So again, just to motivate, this lab DNS is a preview of what the projects will be like, where you kind of have to do things on your own. Are there any questions about projects before we continue with the topic of DNS?
I don't have any, at least.
Make sense?
Yeah.
Good. So it sounds like that was clear. Obviously, I'll create some kind of a Dropbox that emphasizes that. But at this point, you know, points of action, look for teammates, groups of 3, no more than 3. Could be 2 if you'd like, but you know, 3 probably. And start thinking about, you have to wait for the Hadoop lecture, but now you get a feel for what this is going to be, and then start thinking of other things that you might do. All right, so that being said, so now going back to this lab. So as I said, this is kind of threefold, right? There's 3 things. One of them is you put on your system administrator hat, and you're just going to do a configuration in Linux until the service, DNS, is up and running. And then that's great. Then after that, you want to learn how it works, right? So you've been doing Wireshark all semester. You've been doing your reading assignments, right? So that Wireshark is more familiar to you. So obviously you will use Wireshark in this lab, kind of to analyze data, but you will use a few other tools that we'll discuss as well. And so not only do we first set it up as a DNS server, but then you will actually try it out. You're going to test it out using Linux commands and so on. And the third thing actually is that we're going to play with DNS, right? Let's have some fun with it, right? So, you know, what better thing than to do, like to learn how something works than to like reverse it or attack it, right? So we're going to sort of attack it and see what, you know, how DNS behaves so that we can, you know, better learn, you know, okay, well, you know, this is how it works because obviously, you know, I did this attack and this is what happened, okay? So the focus again, you know, with these things, it's not about you becoming a hacker or an attacker of DNS servers or anything like that. It's mainly about understanding how it works, right? By kind of, you know, playing with the packets, etc. So that, you know, that's really our goal. But it should be fun. There's a few fun scenarios here that we'll think about in this lab. So so let's start with the PDF, kind of motivate, because this is really what you'll have to submit, right? And then after that, I will go into I have some notes, some brief notes that I'll cover, maybe some commands, etc., that might be of use to you. As you know, obviously, you will set up, you'll need seed. And actually here, going forward, I believe I said this last week, but maybe I forgot. Going forward, we're not just going to be using one VM anymore. Okay, you will need to use at least 2 in the physical computer. And in some case, you may even need 3, as I've already stated, because, you know, we're now in a stage where obviously you have more, you know, if you're doing like sysadmin work, you would be monitoring at least, you know, more than one computer, etc. So this will be kind of the first example where we need a couple, even 3 if you can, 3 machines, 3 different IPs basically, right? And a couple of those should be Linux at least, so that we can see some interesting behavior. So this is called the local DNS Attack Lab or lab, right? So as you know, and I'll go more formally. I know you guys know what domain name is already, but I will provide a little bit more formal description. Also, your book, as I said, you can see it right there. The details are stated. So let's talk a little bit about it. So DNS is the domain name system. All right. Basically, it is the internet's phone book, right? It translates host names to IP addresses and vice versa. So it's pretty important for the how the internet works. And you know, there's basically, you know, Linux is free, so it makes sense that something that every company needs to have these DNS servers. You know, Linux is certainly a great solution. So this translation is through something called DNS resolution, which happens behind the scenes. DNS attacks, on the other hand, right, if we were to take advantage of how that works, that infrastructure, manipulate this resolution process in various ways with an intent to misdirect users to alternative destinations. Remember that DNS is all about, you know, okay, I need to get to a host name. What's the IP, right? So you need to do some kind of a lookup. So packets are going to be in the background, behind the scenes. They're going to be exchanged, right, back and forth. And so you guys, will use Wireshark and other tools, TCP dump, etc., all the tools that you already know about that we've seen in this semester to kind of get a feel for, oh, this is how this works or that part works, etc. DNS attacks will manipulate this resolution process in various ways with an intent to misdirect users to alternative destinations, which are often malicious. The objective of this lab is to basically understand how those attacks work, and that therefore will also direct us into how to understand how DNS works itself. Students will first have to set up and configure a DNS server, right? So that you're, as I said, you're going to put on your system administrator hat and just configure the DNS server. And then they will try various DNS attacks on the target that is also within the lab environment. The difficulties of attacking local victims versus remote servers will be very different. We're only going to focus on local right now. So this lab this one only focuses on local DNS attacks. Remote DNS attacks, that's something that in network security course you'll cover later. All right, so this lab focuses on local attacks. And so we're going to look at several things. So first of all, obviously, DNS and how it works. So I'll go over the lecture on that topic. DNS server setup. A lot of the information for that is in this document itself. So you'll have to read through it and do the configuration. And then we're going to look at some types of an attacks like DNS cache poisoning attack, right? Changing something, we're going to learn what that is and how we can change it. Spoofing DNS responses, right? So we're going to look at how we can create packets that impersonate the packets of DNS and, some other things. Later on in the semester, we'll cover SCAPI towards the end of the semester, really, which is a tool that we will use in the network security class quite a bit, and it's based on Python, so it should be pretty easy to pick up after 372. So the book, basically the whole book or all the seed labs use Python extensively, and so it's a good tool to look at. All right, as you can see, the readings, if you want to follow along, as I said, hopefully you have the book. You've taken 350 already, or you'll take it next semester. You should have the book anyway. So there's a detailed coverage of the DNS attacks in chapter 15 of that book, Computer and Internet Security, a Hands-On Approach by Winley and Du. But I'll provide the notes myself between today and Wednesday as well. The lab environment, you'll need to use the 1604 VM. You'll probably need to, as I said, get a couple more copies of it. Okay. Okay, so the lab tasks, we have, it'll be obviously part 1, right? You can see that there, which is just setting up a local DNS server. So this is going to be, as I said, you're the sysadmin. You start with a server from scratch. You will have to follow all of these steps, right? You can see that here until everything is configured. You have to configure both the server and the client, okay? Server and the client. And then after that, host a zone. We'll talk about what that is. I'll make this comment now before I forget. Usually these things, it's not a good idea to type these files. All right, there's a lot of hidden characters that will create a problem. Instead, I'm pretty sure the website of this lab on the seed labs has these files in there already, so you can just download them and modify them, but don't type them up, okay? Just these ones that look like this. So I do want to stress that. But we'll talk about that later on as well. All right, and then basically you will do the whole configuration of bind, and then you will have hopefully a DNS server, okay? Now the second part, part 2, as you can see here, part 2 of the lab will be to do the fun part, right? So hopefully you guys will find this to be fun. You know, this will be, I don't think we're going to do any scripting in this lab, or very brief. I'm not entirely sure, but it should be a lot, you know, straightforward really. But you're just, you know, the goal is really to get a feel for how DNS works by running through some of these problems. In particular, you'll do this problem, the modifying the host file, right? So we'll do that one. Should be pretty easy. We're going to do the directly spoofing response to the user. We'll do that one. And then we will use a tool called NetWalks that's built in already in the CVM, so it should make it easy. And then the so-called famous, you probably read about it somewhere, the DNS cache poisoning attack. So we'll take a look at that one as well. That'll be pretty much all of it. I don't think we'll do this one, targeting the, because that would be too much to do. So we'll skip that one probably. Targeting another domain, targeting the additional site. Yeah, so these we will skip for now. Here actually, oh, there is some Python. So there you go. So we'll take a look at that as well. Should be if need to. If we need to. All right, as far as the submission, obviously students, just like every time in this class, students need to submit a detailed lab report to describe what they have done, what they have observed, and how they interpret the results. The report should include evidence to support their observations, through screenshots showing that you did it, not just, like comments, but you should also have this, your own little paragraph of what you observed, answers to questions, etc. This could be packet traces, screen dumps, screenshots. Report should also list the important code snippets, right, with explanations if you used any like Python script or commands that you used of importance. You can always just take a screenshot of that as well. You don't have to type it up. Simply attaching code without any explanation will not receive credit. So don't just give me code without explanation and screenshots, okay? Please. All right. So that's basically an overall view of the lab. Now, don't worry about the attacks yet, okay? Because as we saw in the beginning, this lab, this is why I said I'm not entirely sure if this is going to be a 2-week lab. It probably is. So there are 2 parts. The first part is configuring the DNS server and getting it to work with the DNS client. That should be your only goal right now, okay? Do part 1, get it configured. Remember, you're going to have to configure a lot of things, this semester and for the term project. So get part 1 done, and then once part 1 is done, then you can start working on part 2, which is the attacks part, which is basically getting a better understanding of DNS, right? So that's really the plan. So let's talk a little bit first. Let's continue with the PDF here, and then after that, we'll get into basically like the lecture. All right. So the first part here that you should be seeing is lab tasks part 1, setting up a local DNS server. So the main purpose of the lab is on, of this lab is on the DNS attacks, right? You might say that. And our attacking target is a local DNS server. Obviously, to attack a DNS server, to have that service on our Linux machine, we need to do the installation first. Now, remember, whenever we do attacks of any kind in this class, remember this should be stated very clearly, right? Obviously, it is illegal to attack a real machine. So you can't just try to do this on the school's DNS servers or anywhere else for that matter, right? Remember that this should only be done in your own environment for class purposes. So therefore, we will need to set up our own DNS server to conduct the attack experiment. and to learn about the configuration. The lab environment needs 3 separate machines. One is the victim, okay? One for the victim, one for the DNS server, and the other for the attacker. So basically, you can think of it as having a client-server architecture, right? That is to say, we're going to have a DNS server, and then we're going to have a computer that wants to access that DNS server. Therefore, it is going to be the DNS client, okay? Then after that, we're going to have the attacker, okay? So we're going to have the attacker. All right, so so that's the first part. So you'll need 3 VMs. We will run these 3 virtual machines on one physical machine, obviously. So, with VMware Professional, right? Remember, you should be using VMware Professional. If you haven't done so already, look at the links that I provided in the website, course website. You can see there all the instructions. It's free, so you have a license when you're in this class. So make sure you're using it. On there, there's an option for creating clones of VMs, so you can go ahead and go through that process. All these VMs will run basically they should be clones of the Ubuntu seed VM. That will help you to, because it's got all the tools that you will need. Now, the bottom figure illustrates the setup of the experimental environment. For the VM network setting, don't use VirtualBox, please. And in VMware, just use a NAT network. Okay, that should be enough. As the network adapter for each VM. Okay, that should be good enough. Each one will be they're going to be in the same network, and they're going to give you, each computer will have an IP. Now, the IP that you actually get may not be 10.02. Usually, you get like 192.168 something. So you don't have to change the IPs to match the IPs in this PDF. You can just use whatever ones you're given in the system, as long as the 3 machines have the same network ID, and therefore they're in the same network and they can ping each other. Good to go. For the sake of simplicity in this lab, we just, the machines are on the same network. So here, this example just assumes the following IP scheme, right? Your IP scheme may differ from this one. So you will need to configure the user machine and the local DNS server for the attacker machine as well. So here is basically the scenario, right? So the attacker machine doesn't require any DNS type of configuration, right? So that's the attacker only needs to attack. The attacker will either run a Python script or will run a tool called netwalks, where literally you just have to type on the terminal either netwalks or netwag, and those 2 tools will pop up. That, netwag is a GUI interface based that you can use. Okay. All right, so yeah. Now, the other 2 VMs that you see, the ones in blue here, you can see that one is, notice the IP scheme, 10.02.18, 10.02.17, and 10.02.16. So they're obviously on the same network. They can ping each other. They're in a NAT network on VMware. The attacker does not require any DNS configuration, but the client and the server will. Okay, so user machine 10.02.18 will require DNS client configuration. That is specified in this document. All the instructions are there. Actually, you can see that here. Configure the user machine, right? So that's this one. So that will be because whenever this machine wants to do DNS resolution, probably it's configured to do something right now, but we need to change that so that it only uses the local DNS server that you're going to configure, okay? Then obviously the local DNS server is the one that's going to be running the DNS service. In this particular, it'll run the daemon bind 9, and that's the program that will provide DNS resolution. So user machine needs to do lookups on local DNS server. Okay, so user machine will need to access DNS server whenever it tries to do DNS resolution. So now I'm not going to go into all the details of configure user machine. You can, this is basically like a tutorial, so you can literally just read through it. But just be aware, when you're configuring your user machine, you will follow these instructions here. When you configure your setup a local DNS server, this one, that's for the server, obviously, right? The DNS server. So again, you can just literally read through these. I'll describe like the Berkeley Internet Name Domain or Bind 9. So I'll talk about it in a second in my notes. But this is basically all the instructions on, you'll have to open up certain files. Now, remember, in Linux, it's not GUI, point and click, next, right? You got to really concentrate when you're doing things, because if you make one little error in one of the files, nothing will work, okay? So, as I said, that's why I'm not rushing you by making, I think I'm not going to make this a 1-week lab. Instead, it'll probably be a 2-week lab, where the first part, like for this Wednesday, is simply get bind 9 configured correctly, okay? Remember, that's one of the things that you're supposed to get good at or better at in this class, right? Just configure, dealing with problems in Linux and configuring them as best as you can. So you'll, read this, the instructions are pretty good, but make sure you read this carefully, follow everything. Now these you can type up, these parts here, notice you'll restart the service a couple of times, and then we'll talk a little bit about what zones are. So I need to explain that a little bit, but it's also explained here. And you can see you'll create these zones. And then these files, I'm pretty sure, are on the Seed Lab, so you can just download them from there. If I go to the Seed Lab, we can go later, but the files are there, so they'll look like this. You'll copy them down, and so on. Okay, and that, hopefully, when you get to this, you'll run an exam. Notice the dig command, right? So you guys already know what the dig command is, because it was in one of your previous labs where you had to practice with it a little bit, right? So you had to practice with it a little bit, and now you'll be using it in this lab kind of more formally, more seriously, for its purpose, right? Which will be to test that you did the configuration of your DNS service correctly. If you don't configure the client and the server correctly, you will not be able to do part 2, which is the attacks part, of which, as I said, there are 3 attacks. There are three things that I remember I'm always looking for. But I'll talk about attacks certainly, probably just next week. So I'm going to leave this part for next Monday, and today and Wednesday, we're just going to focus on until here, right? So the steps. So you have step 4 there, and then, step 3. So if you look, then if we break this down into steps, configure the user machine is actually just this, right? So the DNS client is just that. You just have to do this, and it's configured. Configuring the server requires a little bit more. So step 1 is to configure the bind 9 server. Step 2 is to turn off DNSSEC, right? So you'll take a look at that. Step 3 is to start the DNS server. Step 4, use the DNS server, and then after that, you need to host a zone in the local DNS server. So that involves creating the zones, set up the forward lookup zone file, set up the reverse lookup zone file. That we will talk about more in the lecture. And then finally, restart bind server and test that everything is configured correctly. And if you did configure it correctly, then you'll be good to go. Are there any questions so far, guys?
I don't think so.
All right. So what will you need for this lab? So let's go. Let's go to the Seed Labs. All right, and then we can take a look at lab setup. Not there. Seed lab, sorry. So go to this one or the 2004. I think they're pretty much the same. If you go to network security and then local DNS attacks, right? So this one, as I said, you'll do the remote later. Yeah. Oops, sorry. Local DNS. All right, you can see here the two files are provided. Files that are needed, you can see, read through this, but you can see both files are there. Okay, both files are there. And then the VM is here, but that you already have, of course. But as I said, you don't type those two files. Instead, just download them to your machine, and basically you will modify them. But if you type them up, usually I've noticed students end up with a lot of errors. So that's the main issue. All right, so that's the plan then. I've talked a little bit about the lab, and I think that should be well motivated now. And so we should be ready then for the lecture part. Okay, so now then let's go ahead and switch. So now that the lab is laid out, we can talk just a little bit more formally about what DNS is. Okay, so we'll talk about DNS. So then let me switch over to the whiteboard, and then we can start like our discussion of DNS itself. So this is, a more formal definition of DNS, and that will help us for the lab understanding. It says there's a few terms that we need to define for this. So remember, one of the things that you've learned at the very beginning of the semester is that, a Linux server, you can have servers for web, for email. It could be an email server, a web server, a syslog server, whatever it is, a database server, all kinds of servers. The role is defined by the service that's running, right? The daemon, really. In this case, the role of the Linux server, so here, the role, here, the role of the server, so the role of the server is basically DNS, okay? And, as you can see, just one service can be a lot of work, right? And that's what we're going to define here today. All right. Guys, give me a couple of minutes. I just have to take a break. I'll be right back. So just read that through the PDF, please, and then we'll continue in a couple of minutes. All right, sorry about that. All right, so let's continue then with our discussion of DNS. Okay, so the audio is recording and the video is also recording. Okay, so we can go back to the whiteboard. Okay, so we can see here we were talking about how of all the services that we can have, our current service will be, the role of the service will be as a DNS server. Okay, so basically then, this is about managing network services, right? So this is network services. So high-level network operations typically use host names. So that's what we know, right? So in a high-level, high-level network operations, rely on a host name. That's how we remember things, host name, to specify the network location. And this is more convenient because, you know, the other, you know, on a lower level, you know, on a lower level, you have basically the system relies on IPs. And you guys are very familiar with that. But so we therefore need to have some way of mapping IPs to host names, basically. So we need some kind of a mapping function for that to happen. So accordingly, at the most basic level, network operations depend on two essential abilities. Okay, so you know, network operations depend on two essential abilities. One is translating IPs, translating IP address to host name, and vice versa, right? So, and vice versa. And the second one is in determining the route to a desired remote destination, right? So once you have that, and determining the route to follow. Right? And so that's basically what, you know, DNS does, right? And you guys know that. So to do this, so to manage this idea, we need something called DNS, and DNS stands for the domain name system. So it's the domain name system. Okay, so the domain name system, and it's basically a facility that provides name resolution services. So DNS is a facility that provides name resolution services. And that's really the main idea of it. And then after that is just, you know, what are the elements that make up DNS, you know, in order for us to be able to configure this accurately. Okay, so obviously that's going to involve some kind of software, a daemon in this case, that represents the service. So DNS is like a protocol, right? So think of it as a high-level framework of how things work, and then there's going to be implementations of it, all right? So that's the next thing. So DNS, let's think of it as DNS is the specification of services that need to exist and how they need to operate, right? Associated with, you know, port numbers, etc. In Unix, so now specifically to our, you know, our course, Unix, in Unix, the actual implementation is called bind. In Unix, the actual implementation is called bind. Now, bind stands for, so bind stands for the Berkeley Internet domain, name domain. So Internet name domain. So as you know, as you guys remember, when all the internet was being created, you know, Berkeley and other universities had a big role in a lot of these things. And so we have, you know, this service available for DNS. Now so now we can think specifically of what DNS servers, what is the DNS servers? What does it consist of? So let's think about that. So the DNS consists of two distinct activities. Two distinct activities. Okay. And these activities are, but obviously number one, the actual host name to IP address translation process, in reverse, right? So either host to IP or IP to host. So number one is the actual translation process. And this can be host name to IP address, or vice versa, because, and this is something when you do your configuration, you will actually have to worry about, or the IP address to host name. Okay, so sometimes this is called the reverse of the other one, right? So one is forward, the other one's reverse. The other task, besides number one, is that there may be more than one DNS server. So you might have two DNS servers, and so the two DNS servers don't always have to talk to. They don't always just deal with clients. Sometimes between themselves they need to communicate. All right, the DNS servers. And so what that is usually referred to is that there's an actual distribution mechanism for the translating data. Okay, so the second activity would be the distribution mechanisms for the underlying translation data. So the scenario here is, think of this, right? So if you're somebody that wants to reach a specific host name on the internet somewhere, you're going to have to query. Now, let's say you're this one and you query this server, but it could what would happen if this server is down for whatever reason? Then you want to have maybe another one, right? Another option. And that other option is basically just a replica. So these are replicas of each other. So the way that they stay in sync or become exact replicas of each other is that there is some underlying distribution mechanism for the underlying translation data. Okay, so think of it that way. Okay, because otherwise, usually companies will have multiple DNS servers, which are basically just replicas of each other, and they have them in different places, right? So the different geographical locations, so that if, let's say they had one in Texas and they had what happened in Texas in the winter this last week, well, you also have another one in, I don't know, Georgia, and in Georgia, that one was working fine. And so that's the underlying idea. So now, what is DNS? So structurally, DNS is a database. That's really how you can think of it. DNS is a database, or is rather DNS, we can think of it as is a distributed database whose contents are spread across the entire internet. So it's a distributed database whose contents are spread across the entire internet. right? So basically individual DNS servers store only the subset of data for which they are responsible, right? So, each company basically has their own data. There are some central DNS servers, some top DNS servers that you can query, and basically all they do is tell you, okay, if I'm looking for something, where should I go to look to resolve that IP, right? But ultimately, individual DNS servers only store a subset of the data, and it's usually just the data that they're responsible for their site. Now, so how does something like this work? Well, it basically works by queries. And this is one of the things that you will see in your lab, right? So you'll basically see a packet that goes out. It's like a DNS packet. And it's like it's got a question mark. Who is so-and-so? And so that packet is going to be sent from your client. Well, it's going to be sent to the DNS server that it knows. But if that DNS server doesn't know who that is, basically that DNS server will forward the packet somewhere else, right? So basically, queries into this massive distributed database work because DNS has an ability to forward translation requests. So queries into this massive distributed database work because of an ability to forward. So because of ability to forward request. Okay, so you forward your request. So one DNS server then, let's say this is the client, sends the request. That DNS server doesn't have the resolution. And then there's a mechanism that allows that DNS server to query someone else, right? Eventually, if you're not finding the resolution, it'll go to some upper level DNS server that might then point you in the right direction. Okay, so you can think of it, well, if you're looking for a .org, right? Okay, and you're just completely lost, you're going to be forwarded to some .org domain server. That .org, then it's going to start looking, okay, I only focus on .orgs, and then I'm going to, or .edu, right? And then figure out, oh, this is, I can send it in this direction. So it's a mechanism. It's like a web, right? So it's like a web of DNS servers that can look at other DNS servers, and until you have a top level where they can redirect the traffic. But basically, all of it works because of that idea of redirection. Okay, so queries into this massive distributed database work because of the ability to forward requests. And that's actually one of the big things that you will notice in your one of the big observations in this lab, right? Is that you're going to see through Wireshark, etc., that process of the forwarding of the request. Also, because you'll do the attacks, you will actually try to take, exploit that ability to get a better understanding for DNS itself. Okay, so the domain names, as we know, domain names are arranged in a tree structure. The domain names, which are the ones that we're familiar with, are arranged are arranged within a tree structure. Right, and this kind of translates directly into the DNS servers themselves. Okay, and there's of course going to be a root domain somewhere, usually a root like this, right? And then from there, it's going to be divided into the different domains. Underneath the root domain are a series of top-level domains whose names take basically one of two forms. So let's think about this. So basically, let's imagine this is the root domain, and then you basically have two groupings at least, right? You have what are called the generic suffixes, which are basically what? These are the type of organization, right? So these mean like type of organization. And all of this was created a long time ago, but they basically represent, the .biz, .com, .edu, etc. Right? So all of those. And then the other classification is the one based on country codes, right? So the 2-character country codes, which were designed in the past for just individual countries, right? So, for instance, .us, .de, Japan, something like that. So they indicate the individual countries. Nowadays, a lot of these, like .ai, I think .ai was actually some country. You can look it up. I'm not exactly sure which one it would be. But now you can actually just buy a domain in those areas as well, because AI, now people that are in AI may want to have a website called, anonymous.ai or something like that. But these were originally the classifications that you had. And if you think about it, whenever you think something that might strike you is that we always think of domains as going, I don't know if you've ever thought about this, but you think about domains like this, right? We think because we read and write from left to right, we always think in that direction. But actually, technically speaking, this was designed in the opposite direction, like that. So if you think about it, it starts at root, which you could argue is like here, right? So that would be root. And then the first thing you look at is what, what's the classification? Am I a country code or am I a, so then you start, you go from this direction, right? So first you start at .edu, okay? And then you say, PNW, right? The institution. And then over here, this is actually important because this indicates the web server, right? Just like if you do, for instance, DNS, let's think about DNS, you would do, PNW has DNS, so they would do edu.pnw, and then I think it's either DS or DN, I can't remember right now. It's you'll see it in the PDF, I'm sure. If anyone is seeing it, let me know. But it'll be something like that. Mail could be .edu again, start there, PNW, and then mail. So this is how, how the domain works. And actually, if you think about it, as I said, the way that is written is to be read in that direction. So this part just indicates the server that you're talking about, which usually will translate to an IP address. So that will be some kind of an IP address. And that's relevant because that's what we're going to be configuring in the lab, right? So we're going to be configuring this in our lab in that sense that you will have to create these zones. We'll talk about zones in a sec, but these zones you have to say, well, .edu, .pnw, and then I have my servers, like I have a web server, right? So that's going to be 192.168.1.17, and then you're going to say .eu pnw.mail, right? And mail is going to be 192.168.1.4 or something, right? So this is what you will have to configure in order for this to work. Obviously, you're in your zone, you're only going to have maybe a web server and a domain server. You're not going to have mail or anything like that, but obviously you could have all of those things configured in there. Okay. Any questions so far, guys? Any questions?
No questions.
Not at this time.
All right, great. So that kind of gives us, you know, an overall big picture, right? We talked a little bit big picture about DNS. We have to provide some kind of a definition of it. Now the next set of notes just rely directly on bind, right? So now my focus, we're going to switch from the, you know, because we define DNS broadly as a distributed database whose contents are spread across the entire internet, and it's basically an not an implementation. It's a facility to provide name resolution. It's a framework, right? It's a framework. But now we are going to focus more on, DNS is the specification, and in Unix, the actual implementation is called bind. So we're going to take a look at the implementation itself, and this to give you a little bit more sense as you guys start to do your configuration of it for the lab. So as I said before, basically, you know, the implementations now of DNS, such as bind. So, you know, so let's just say DNS implementations including bind include, you know, have the following usually. So have the following. Okay, so they will have the name server itself. So the name server. And what is this? This is basically the daemon, right? So we already defined what a daemon is. You should know what that is already, right? That's just some software, right? Some code, firmware, whatever you want to call it. So on Unix, this is the daemon. The daemon, and it's called basically named or named. Remember, it's name, and the convention is named or named. The D stands for the domain, and this is the service that you will have to enable and then configure, right? And it's configured as everything is in Linux via configuring a whole bunch of text files. Okay? So you will do that like that, the configuration. And then the other part, obviously, if there's a daemon on the server, then the other part is what is called the resolver, which is, you can think of it as the thing on the client. So the resolver is a library, let's say, a library used by commands and programs to resolve, right? So it's a library used by programs, user programs, you might say, programs to, let's say, request resolutions. Which makes sense, right? So you can think of it as the client-server architecture there. All right, so, and And that's why when you do your configuration, you have to configure the DNS server, and then on the client, you have to do some configuration as well. And then computers just have built-in solutions to do the queries themselves. So you don't have to actually program that. Now, the next thing that we're going to talk about, because it's important for what you're doing, is something called zones. Okay, so zones, you probably saw that if you started reading the PDF, you saw that DNS works with these zones. Okay, so the first thing is we probably want to define what zones are. So name servers provide name resolution services in the form of DNS zones. Okay, so name servers provide name resolution services in the form of DNS zones. So what are these? These are some files, right? So these are nothing more than files, and the files organize information. So these are nothing more than, these are files that organize information. And this is what you guys will actually literally have to configure. All right, so they look, like this idea, right? Files with, there's more there, but really all you have to worry about is these parameters. Obviously, the tutorial is using the IPs that it used for its scheme. You have to use here the IPs in your NAT network, okay? So don't forget that. So now the formal definition of a zone, let's look at a formal definition of a zone. Okay, so a zone is the name given to the collection of hosts within a domain. Okay, so your domain will, here would be what? pnw.edu, right? So that's the domain. So let's say domain would be pnw.edu. And then according to this definition, a zone is the name given really to the file, but let's just say generalize it to the collection of hosts within that domain. Well, yeah. So the zone here, domain pnw.edu, is basically these two hosts, right? www. Which is the web server, and mail. Which is the email server. And of course, you can have several more. You can have the DNS server. You can have all kinds of things. Whatever servers you have available in your network, database, etc. So a zone is the name given to the collection of hosts within a domain. Okay, and that's basically the idea there. Now, there are two types of zones. There are, let's say, two types of zones here. So there's basically let's call them the forward and reverse. And it's really the same information, but just in reverse. Just to speed things up, it's good to have both of them for a quick lookup. So in the forward, basically they would hold records that map host names to IP. or IPs. And this is, for DNS, for the DNS queries, of course. And then the reverse lookup. So this is reverse lookup. Zones and are used to perform the opposite query. So here you're going to have when you have a mapping of IPs to host names. Okay, so IPs to host names. So I don't know what you mean by a stack, but they're basically just files, and you will configure them when you do the DNS. You will have two files literally. So it's like this is a file, this is a file, file 1, file 2. They'll have unique names, and they're associated with the bind service and the domain that you have. You know what I mean? They're literal text files that contain just the information. You'll see this in a sec. Any other questions? Yeah, it's not a data structure. In Linux, think of it. You configure what is the Unix way, right? What was the Unix way in Linux?
Everything is a file.
File. Simple, elegant, right? And these are just files. Those are those two files actually that I showed you guys a second ago when I went to the Seed Labs. Those are the two ones that you download. They had one is the forward, one is the reverse. And really, there's a lot of information there that you don't need, but really the only things that you will have to change are these mappings of host names to IPs versus IPs to host names. You see that, guys? Because, think of it this way, even if you don't have a mail server, right, or you don't have a DNS server, you can still use the dig command to ask your server, hey, what is the IP address of my mail server? Do you see that? And so if you said in your configuration, right, in your zones, that it is 192.168.1.4, when you do the dig for mail, you should get 192.168.1.4. If you did a dig for www, you should get 192.168.1.17. Does that make sense, guys?
Yeah, that makes sense.
And this is actually, I'm glad I got that question, because that's a screenshot that I need to see in your lab, okay? That's how I know you should, just for your own. This is not even solving the problems or anything like that. This is just, does DNS work? Well, you need to do these lookups. If you told me that you configured in the zone these IPs, then that's what I need to see. All right, so it's, these values are pretty important because they tell you that it's querying things correctly, both for the in the zones files, basically both for the forward and the reverse lookup. Okay, but good questions. All right, so now we talked about what the zones are. So good question. They're just text files. They don't have an extension like .txt or anything like that. I don't remember. I think it's .db, to be honest. There's something like that, but they're really literally just text files. All right, so that's one of the things you'll configure. Again, I stress, download these. Don't type them up. But you will need to modify them in particular for this, right? These mappings. Okay, now the next thing, just some quick trivia. BIND. BIND was first started in 1984. So think about it. When the internet was just starting out, it was kind of thought of, and it's, still works. So pretty good. Now in Unix, how are you going to do your configuration? Obviously follow the PDF, but there's going to be a master configuration file. So BIND will have a master configuration file. All right, so bind has a master configuration file, and it's usually called named dot configuration, basically, and you can find it in the etc folder. We haven't looked at the file system so much so far, but remember, etc is really, whenever you're doing configuration, etc is the folder where a lot of configuration files will be. You have to open this. How do you open it? With nano, right? You might need root privilege or permissions. So how do you do that? ls-l, right? Check out the permissions, you know, and then you might need sudo nano etc name config. Also remember, one of the recommendations was, because you might ruin this somehow, what did we say about that? CP, right? Name configuration, and then named configuration.backup, just in case. Otherwise, you'll probably have to download a new instance of the VM. All right, so those are just a few things. Now, as far as the files themselves, in some of these files, the files follow a specific syntax. Okay, so there's a specific syntax that you should be aware of. And it's usually something like this. So there's going to be whatever it is that you're doing in that file, you're going to add an entry which has a keyword. You know, whatever it is, the keyword, it might have some arguments which are optional. And then it uses curly brackets to specify the content, so, and semicolons. So in here you might have a comment. So this is a comment. And then after that, you have whatever your items are. So item, semicolon, item, semicolon. So a lot of this is just in the PDF itself, but just be aware this is the standard syntax. So for instance, if we were to do this, let's do an example here. Okay, so it's going to be options, and then open curly bracket, close curly bracket, right? And then here, one of the options is for whatever that file is, maybe you have the directory, okay, is, var named somewhere else in the file system, maybe another configuration file, it's located there, and the file name could be named.cache. Right, so this is just an example to give you an idea of the syntax. As I said, the PDF itself will be pretty clear and descriptive. All right, so we're almost done, with this lecture. So we'll be able to work on the lab on Wednesday. And as I said, all I want you to do on that lab is part 1, getting things configured correctly. All right, so as we know then, and to kind of summarize, right, so name resolution. So the term name resolution just refers to the process of translating a host to a corresponding IP. So it seems like a very trivial thing, right? But we almost never think about it, and yet, it does require some detail. So there's an additional thing for name resolution. I don't know if you're familiar with this, but who can tell me, in Linux, what is the purpose of this file? Oops. Let's see if you guys know. What's the purpose of that in Linux? Nobody knows what etc host is?
It's the IP host names, DNS and IPv4, if I'm correct.
The IP host names of what?
Of the local machine.
Not just the local machine, but yeah, so it can be resolution of a lot of things, actually. So think of it this way. There's a process to name resolution, right? Let's say that you're the client. Let's say you're the client. This is the server. Actually, before you, let's say you want to resolve something, right? Let's say you want to resolve something. Before you send the query, and this is one of the things that you will test in the lab, right? So the lab problem 1 actually, or part 2, is exactly this scenario. It's easy, it's super easy, but you will explore it. Before it sends out a query to the DNS server, this is the DNS server, the machine, the Unix machine, will check its local etc host file. And in that local etc host file, you can put in mappings of as many domains to IP. So if you, one of the things I recommend that you do is go to your CVM and check out this file. So you can do, cat etc hosts. Take a look at that file, and you'll see a lot of IPs. Usually you have the redirection IP 127.0.0.1, and you will have other, you might have other IPs in there, but you can insert others for other machines in there. And the machine, the DNS client over here, will check out that file first. If there's nothing there, it sends out the query. However, if there's nothing in there, however, if there is something in there, it'll use it actually. Okay. So now let's take a look. So that's basically the idea. That's what etc hosts. So the steps, the IP address can be looked up in a file. In Unix, the list of translations is traditionally stored in etc hosts. Okay. If that's not there, then the client, step 2 would be to contact its own domain name system, which you guys will configure, and ask it to perform the translation. Usually you guys know, I'm sure. Oh, another thing is 8888, all 8s, right? That's who is that? That's Google, correct? That's Google's DNS. I'm not mistaken.
Yep, that's their main DNS.
It hasn't changed yet. So yeah, exactly. That's another thing that you can look up, right? You can look up these DNS. We probably, usually don't think about these things because we just get something via DHCP or something like that. But just be aware, there is actually this. So problem 1 of part 2 addresses this file. So you'll get to play with that. So that, if that file doesn't have the resolution, then the client can contact the domain name system and ask it to perform the translation. Now, obviously, if you're on the internet, looking for things on the internet, using the DNS infrastructure is the only practical way to translate host names. But the way that this etc file, so if you were to do, let's say you did cat, you should know what cat is by now, etc host, right? So if you do this file, it'll probably show, I think at the top, 127.0.0.1 localhost, right? But then it's going to show maybe 192.168.1.2, and it just would be another host name that you're using. And you can even repeat host names. So this could say Canada, the Canada office or whatever, other hosts. So you can, it's a list of individual things. So the best way to get a feel for this is to take a look at in seed. So in seed, the CVM, take a look at that file and you'll see a lot of information in there. Now to configure it, you'll follow the instructions on the PDF, so I won't go into the details of that, but it's very simple, really. And it really just centers around like the etc resolve configuration file. All right, so for the client side, DNS client, the file should be, again, nano, maybe sudo. So you need to check the permissions, etc resolve .configuration. Keep in mind, you know, I always want to stress, right? These are Unix. Whenever I say Unix, because although we use Ubuntu, there is Red Hat, you know, there's a lot of versions, different versions of Linux out there. They're all pretty much the same, but finding these files sometimes varies. You know, they might have different places where they put things. So these are generic for Unix. Usually this file, the etc resolve configuration file, will list the local domain name. So, you know, basically which domain name you should be using. So the file then, if you opened it, you know, would look something like name server, and it might be like 8.8.8.8. Obviously, if you're using this in your client, you know, the lab won't work because you're always going to resolve with Google's thing. You have to change it to whatever your DNS server IP. So 192.168.1.17, and that's going to be your DNS server, the IP of the bind server that you just configured. But there, you know, as I said, just follow the PDF instructions. Those are pretty good, pretty clear. All right, so we're doing good on time. Now we are, you know, let's see if we have a few commands. So just, you know, Linux command time. So a few Linux commands that might be of use for your lab. All right, so what are they? Netwalks. So you go and you'll probably do sudo netwag. When you do this, a GUI will open. So this opens a GUI. This will allow you to create for part 2. This will only be for part 2 to create the attacks. If you want to do a specific attack, I'll give this command later, but it's sudo netwalks. When you guys need it, just let me know, or you know, I'll get to it. In the lab, sudo netwalks. I can't remember the number for this, but there's a specific number for that attack. We have, you know, usually the netwalks is like 102, and that's an attack, you know, and so a specific type of an attack for DNS. So I have to look, you know, I can't remember what it is right now, but just, that's kind of the format of that. You can do things like on the terminal, who is, and then let's say, you know, pnw.edu. So you can check that out, right? You can do what else? We talked about bind. We said that it's called name, right? So because we said it's called name, if you want to know if bind is running on your Linux machine, so let's say, is bind running? What do? We've already talked about this. You can go to the terminal, type PS, right? That gives you all the processes. Type in AX, for instance, the flag. Pipe that into grep, and then just say name. And this will show if among the processes that are running, you can see your name process there. So let's find out if bind is running on your local Linux machine. What port number does bind use? So bind uses, or DNS in this case for Unix. So bind, or the, let's say the name server, the named daemon, actually listens on port 53. For both UDP, oops, UDP, and TCP request. So if you want to take a look at it, you could say something like netstat-na pipe grep, and then try either TCP or UDP. And take a look, and then you're going to look at if that port is open, basically, as we have done before. Now, in the slides, it says if you want to, or in the handout, it says if you want to install bind for whatever reason, that's just sudo apt-get or apt install bind 9, I think. But I think by default, it's already installed on the seed VM. So this would only be for people that like to use their own VM. I know some of you have your own computers, you know, your own like Linux versions. You might want to check out this folder if you'd like. Go to etc, cd into etc init.d bind 9. Take a look at the programs there. That should be an executable that you can start, stop, restart, etc. What time is it? All right, so it's 3:40. Let's see. Let me see if I have anything else. We talked about the etc host file, host configuration. Talked about the hierarchy. Now, let's say that you want to look, this one's important. Actually, it's in your PDF, but I'll just stress it. So if you want to look up something with dig, right? So you've already, I think, tried this. You can do dig, you know, CIT, let's say. I don't know that domain exists, but pnw.edu, right? So you can look up information about a specific domain. Can get information about the root servers, etc. So let's say that let's think of a scenario. Let's say that you were getting some spam data, right? Let's say that somebody's spamming you. And you get, let's say that you get spam from 58, I don't know what that IP is, but 62.229, right? So let's say you're getting a lot of spam from that, and you just want to know who it is, right? You want to, who does this belong to? So you can do a reverse lookup. Reverse, because you have that capability. We talked about the zones, so you can do a reverse lookup and type something like dig-x and then 58.9.62.229, and hopefully you'll get, who is it that is spamming you. All right, so that's pretty much it. Yeah, so I've gone over most of my notes here. Talked about the setup for the lab. I still need to give you a few more things like that specific command, but I'm not so worried about that right now, given that right now you just have to complete part 1. We will come back to this probably on Wednesday. I'll take a look at my notes again, specifically as it relates to the PDF. But I think this is pretty good enough. Motivates the problem for this week, and it motivates, a few things that you can do with DNS. So hopefully all this is clear. Start working on your lab if you'd like to, and then just keep in mind we'll work on it on Wednesday, okay? All right, so this is a good stopping point. I'm going to pause the recording.